Welcome students. In the previous class we actually discussed about the last part of your chapter, that is magnetism. Okay, and already this chapter is completed. Okay, today we are going to discuss about actually exercise problems. Okay, so first of all, the first question, that is from your textbook: which of the following is a non-magnetic substance? Okay, so here actually the options are iron, nickel, okay, cobalt and copper. So the correct option is copper. Okay, and the next one is: the strength of a magnet is strongest at its center, one of its pole, both the poles, and none of these. The correct option is both the poles. Okay, and its center, actually the strength of magnet is approximately 0. The next one is: the surest test of magnetism is repulsion, is the correct option. Okay. Next, the region around a magnet where its magnetic force can be experienced is called its magnetic field. It is the definition of magnetic field. Next, which of the following methods is used to magnetize a magnetic substance without touching it? Okay, by a magnet. Without touching, that means by induction method. Okay. The next one is: a permanent magnet can be demagnetized by hammering, heating, rough handling, all of these. Actually, all these hammering, heating, and rough handling is the cause of demagnetization of a permanent magnet. So the correct option is all of these. Now we move our next part, that is fill in the blanks. So the first question is: the force exerted by a magnet is called, actually magnetic force. Okay, so the force is magnetic force. The next one is: a freely suspended magnet always come to rest in the which direction? It is north south direction. North south direction. And next one is: magnetic poles always exist in pairs. Okay, we cannot get a single pole, it always gets pair. Then a north pole does another north pole, it is repel, or you can say repels. Okay, another north pole. And a south pole attracts a north pole. Next, inside the magnet, the magnetic lines of force begin from the south pole, okay, and ends to the inside the north pole. Outside the magnet, actually the magnetic field lines starting from north pole to and ends at south pole, but for inside the magnet, actually it starts from south and it ends at north pole. Next, the north pole of the imaginary magnet of the earth is near the geographical north. Okay, geographical north pole. And question number 7: permanent magnets are generally made of iron, steel, cobalt, nickel, and also or an alloy called alnico. Okay, this is called alnico. Now we move our next part, that is C. Write true or false, correct the false statement. Okay, so first one is: in a magnet the region of strongest magnetism are near the poles. Okay, so it is true. The next one is: if a bar magnet is cut into pieces, then one piece will have only north pole and another one will have only the south pole. This is actually false. So The true statement is actually if a bar magnet is cut into two pieces, then both pieces have north and south pole. Okay. Now the next one is a magnetic north pole attracts another north pole. It is also false. So the correct statement is a magnetic north pole repels another north pole, or you can say another one statement, a magnetic north pole attracts another south pole. Okay. Now the next one is magnetic lines of force are straight line. It is also false. It is not always straight line. It is curved line. Okay. So you can say magnetic lines of force are curved lines. Now the five electromagnets are temporary magnets. It is true. Okay. Now the next one is magnets are used in the closing mechanism of a refrigerator door. It is also true. You can say. And the question number 7, whenever a magnet is not in use, it should be stored along with other magnets. It is also true, but in opposite pole. Okay, so you have to check it, or you have to take care of this. Okay, now we move our next part, that is question number part D. Answer the following in short. First one is give two examples each of magnetic and non-magnetic substances. So magnetic substances, iron, nickel, you can say this is iron, nickel. And for this part, non-magnetic substance means you can say copper, plastic, wood, etc. Okay. Now the next one is how does the strength of a magnet change along its length? Okay, so it is actually the attractive power of a bar magnet gradually reduces as we move from one end towards the center of the magnet where it is practically zero. That means at the extreme point the magnetism force or the magnetic field is very strong maximum, and when we go towards center it decreases, and at the center of the magnet it becomes zero. Now question number 3, if a bar magnet is placed over iron fillings, where will the attraction of the iron fillings be the maximum and minimum? Already we discussed, actually it is maximum at the extreme point or at the end or at the poles of the magnet, and minimum at the center of the magnet. Actually at the center magnetic field or strength of magnetic force is nearly about zero. Okay, now we move our next question, that is question number 4. So for this question, define the following terms actually regarding a bar magnet. So first one is actually magnetic axis. Okay, so for this question you actually get the answer from your book, that is page number, you can say 84 and 85. So first one is magnetic axis. It is an imaginary line, okay, which is connected between magnetic north pole and magnetic south pole of a bar magnet. So that means if you take an bar magnet like this one north, this one south, then this imaginary line connecting between north and south pole is called magnetic axis. Now the next one is B, that is North Pole. Okay, so it is basically the point near the ends of a freely suspended bar magnet that points towards geographic north. Okay, that means if you take a bar magnet and it is freely suspended, then its one pole actually directed towards the geographic north. This pole is known as North Pole, and another pole actually directed towards the geographic south. This pole is called South Pole. Okay, and the last one is actually magnetic field. Already it is discussed. Okay, magnetic field means actually you can say the region in which magnetic force of a magnet is felt by the other magnets or magnetic material. It's called magnetic field. That means around a magnet you get a region. Inside the region, uh, any other magnet or magnetic material felt any type of magnetic force. So this region is called magnetic field. Now the question number 5, that is, why is it not possible to isolate a single magnetic pole? That means we cannot get any single pole, that means only north, only south, this type of pole we cannot isolate, or it is impossible to isolate. Why? Because actually in generally magnetic poles always exist in pairs. Okay, and also you can say that poles cannot exist independently. If you break a magnet, suppose you break a magnet in two parts, then you get two parts, but both these parts have actually north and south pole. Okay, so you cannot get two different poles, or you cannot get one pole in isolate form, because poles always exist in pairs and poles cannot exist independently. Okay, independently. Now the next one is question number 6, that is actually name a few common appliances that use magnets. Okay, already you know some devices or appliances that is made by magnet, or in where actually magnet is used. Suppose you can take magnetic compass, okay, and computers, speakers, televisions, ATM cards, okay, credit cards. In this case actually we use magnet. Okay, now we move our next part, that is answer the following in details. So here you can see the questions. So first one is actually describe the directive property of a magnet. Directive property, already this is discussed in generally when we discuss properties of actually magnet. Directive property, you get the answer of this question. Actually this is page number, you can say 82. Okay, so here you can say that a freely suspended magnet always points in the geographical north and south pole. Okay, this is known as directive property. Okay, and you can say also that every magnet, irrespective of its shape, has a north and a south pole. If you use a bar magnet and using a thread, actually if a bar magnet is suspended freely, then it always directed towards north and south pole. Okay, now the next one is, how will you test if a given metallic bar is a magnet or not? So it is basically test for a magnet. Okay, so you have to take the answer from actually repulsion test. So you have write down a test that you can get from page number 84. Okay, so from page number 84, already discussed, repulsion is the surest method, okay, by which we can get a metallic bar is a magnet or not. Now we move our next question, that is list the properties of magnetic lines of force. It is also you can get from actually page number 85. Okay, here you can say that magnetic lines of forces are continuous curved lines. Okay, and outside a magnet, lines of force start from north pole and ends it south pole, but inside the magnet it's actually start from south and it ends to north pole. No two lines of force ever intersect at a point. Okay, And the next one is, you can say, densely populated lines of force indicate a strong magnetic field, whereas actually widely distributed lines indicates a weak magnetic field. And you can also say that magnetic lines of force show the direction of the magnetic field at each point around the magnet. And now we move our next one, that is, how is the single touch method of magnetism different from the double touch method? It is actually magnetizing method, and you will get the answer actually from page number 88. Okay, so from page number 88 you will get the answer. Actually, two processes are different. For a single touch method, you can take just one magnet. Okay. And you take a magnetic needle or magnetic iron needle or a magnetic material, and using the bar magnet you just place the one pole at one end of needle, and it slides it slowly along the needle to the other end in one direction. Okay, this is actually first, or you can say, single touch method. But for double touch method, you take one needles, two magnets, and actually actually at the middle of the needle you touch with two poles. That means one is north and another one is south of two different bar magnet, and similarly you slide, but in opposite direction. For one magnet you take is as a clockwise direction, and for one magnet you take it anti-clockwise direction. So this is the difference between single touch and double touch method. You will get the answer from page number 88. And question number 5, in this case, how can you make an electromagnet? So simply actually you have to write an actually activity. In this case you take an actually soft iron core and insulated copper oil, a cell, a key. Okay, and at first you have to just wrap the soft iron core with a insulated copper oil, and actually between two terminals of insulated copper coil, actually you just use an cell. Okay, using the cell, you just actually flow, take with the help of electric current, you make the iron rod or iron nail, or you can say soft iron, actually transfer into a magnet. Okay, this is actually electromagnet. What is the material used at for the core of an electromagnet? It is obviously soft iron, because iron does not retain its magnetism once the current is switched off. Okay, that is why we just it is used, and we can say it is a temporary magnet. And now we already you can get the answer from page number 89. Okay, now we move our next one, that is difference between a temporary magnet and a permanent magnet. Okay, also you will get the answer from page number actually 90. Here you can say that for permanent magnet, actually magnetic properties are permanent, but for electromagnet or temporary magnet, it is actually temporary magnetic properties. And for permanent magnets, poles cannot be reversed, but for electromagnet or temporary magnet, poles can be reversed. Okay, by changing the flow of current, by changing the direction of flow of current. And strength of a permanent magnet cannot be changed, but strength of a temporary magnet can be changed with the help of current. Okay, and also the number of turns in insulated wire or coil. Now also you can say that actually for permanent magnet it does not need an electric current act as a magnet, but for temporary magnet we have to use an electric current. Okay, Now we move our next question, that is how will you store magnets. Okay, so this question you can get actually from page number 91. Okay, here actually, if the poles of magnets are left free for a long time, they tends to become weaker. Okay, so this is called actually self demagnetization. Okay, so actually, when we kept two magnets together, then there will be a mutual attraction or repulsion. Okay, and sometimes actually magnetic or magnets will lose their magnetic strength over a period of time, but to avoid this we have to use actually magnetic store using magnetic keepers. Okay, and it is basically magnetic keeper is a basically soft iron bar. Okay, while storing bar magnets using magnetic keepers, two bar magnets are placed side by side with their opposite poles at the same end. Okay, with the opposite poles in the same end. So just we have to use magnetic keepers. Okay, to keep or to storage to store the magnets safely. Okay, and here actually the next part is actually draw following diagrams. Okay, so actually this is not necessary. Okay, so this is not required for your final exam, so I actually put cross mark. Okay, so no need to draw this type of diagram here. Around a bar magnet, draw field lines between two magnets like pole and like pole. Okay, so just read through this question. Okay, that is discussed in this class. Okay, and already chapter is completed, so you can say that here actually okay, when true for true false actually the seven question number 7 is where whenever a magnet is not in use it should be stored along with other magnets. Okay, but using magnetic keepers. Okay, it is true, not stored. It is not actually possible. Okay, it is stored, it should be stored along with other magnets by actually placing two different opposite poles at the same end. Okay, so this is the answers. Okay, so and also the chapter is completed. In the next class we revise another one chapter. Okay, so this is the end.